As introduced, my name is Lorenzo Mangani. I'm from QXIP and the SIPCAPTURE team. Our flagship project is HOMER, and today we're going to give you a little bit in introduction as of what we do, what our product does, and hopefully how it can make your life a little better if you use it. First of all, just a little bit of background. The project is run by myself and Alexander Dubovnikov. We've been playing with this now almost 6 years since the first version. Is it gone? And HOMER started as a very small idea. So back at the time, we were using some very expensive commercial products to do the job, from companies such as Empirix or IPTego, just to name a couple. And they were just out of budget for anybody which was involved with open source, completely out of scope. So we have decided to try do it ourselves. And this is how HOMER was born. We'll see what it does. It's all about SIP troubleshooting, as the title says. So, story of our life. We have trouble. We got to figure out what's wrong and how do you do it. So here I try to give a little breakdown of the typical areas of investigation when we deal with VoIP and problems. So it's just a little bit of an overview just to introduce the areas that we'll touch. So typically sorry guys, over usage we will encounter a bunch of interoperability issues. As the list says, we have different vendors implementing standards their own way sometimes. Different implementations of RFCs, must and should sometimes are loose. Simple misconfiguration. So, sometimes you just have so many options that you get one wrong and you won't find out until you're doing interop with somebody else who did it right. Negotiation is another big one, and probably maybe the major one. So everything from codec negotiation, net detection and handling, SDP, paths, you name it. I'm sure you guys have more examples that I could list here already in your head. System performance. So sometimes we just overstress our systems and we don't necessarily see that just from plain signaling. The call is failing, why? What's happening in the back? We'll see how we can help you with that. And sometimes you're going to be under attack. Sometimes somebody's going to be just scanning your network and eventually kicking out your actual customers or impacting your service. And of course, network performance, ALG issues, and everything down to media stream characteristics. So, it could be latency jitter that you're trying to detect on your network or get out of your devices. And of course, OSI 8, human error, which is also a major one. And sometimes, you get escalations and there is absolutely no problem on your network and you just got to prove it. That's the last case. So it's also useful when you don't find anything. You can just assume that the customer had an issue on their network, for instance. Simple as that. So how do you do it? So this is, again, story of our life. When you need to figure this out, you need access to the data. You need access to the session, and you need to know what was happening at the moment. So regardless of your exact title or your job condition, I'm sure we all have to deal with this eventually. And there you have a bunch of tools, mostly console tools that we are all well familiar with. Here we have just a small list for representation: TCP dump, Wireshark, T-Shark, ngrep, SIPgrep, SNgrep, PCAP SIP dump. You probably know more. But there's a bunch of tools that do a piece of the job. And more likely than not, you have to use many of those, or all of those even, sometimes. Overlapping feature, and so on. It's up to taste, but none of those can just do everything end to end. And this is what we're trying to show today. So let's see if there's a better way to get the job done using our tools, and if they can fit the bill for you guys. And introducing HOMER. So just to get a scope, by raise of hand, any of you already know or use HOMER at all? Okay, good. Then we go from scratch. So what is HOMER? HOMER is part of the SIPCAPTURE suite. What we do produce is actually a series of tools that work together to produce a unique environment where you can do all of your troubleshooting at once. It's sort of a permanent capture solution. So once you set it up, it just keeps capturing your packets and storing them in a centralized collector where they stay available for as long as you want. So you can set your own rotation, you know what's happening on your network, you know how long you have to retain your data. And with HOMER, just a matter of locating. Sorry if I'll keep blowing my nose, I have a bad cold. With HOMER, you really just need to allocate the proper space to store everything. And that's really it. It's very simple. What we do is try to provide a turnkey solution. So we want to give users a unique environment where they can just immediately access everything that has just happened on their network. So present and past signaling, statistics, where you can do full inspections of all of your methods, where you can easily find a call, a session from one of your users, or where you can troubleshoot an escalation immediately. We do provide correlation of sessions, so the system can be configured to know how your back-to-back user agents work, to know how your network translates sessions, how to chain them back together. It's fully visual, so we have call flows. You don't have to deal with any console or even look at the messages sometimes. So very often, just looking at the call flow gives you already the answer that you're looking for. It's quick to use, so it doesn't have a lot of complexity. We keep it very simple. Most of the times it's a one-click deal to get to the information that you want. We're completely agnostic, so it doesn't matter what system, what soft switch, what back-to-back user agent you're using. It matters in a way that we can make it easier if you use an open source one, which we already support, but it could be just about anything. So we have actually networks and users which are using this with platforms that have absolutely nothing to do with open source at all. As long as it's SIP, as long as it's standard, we can deal with it. We provide our own capture agents. We'll show you about that later on. We use our own encapsulation protocol. It's called HEP. It's HOMER Encapsulation Protocol, also known as EEP, Extensible Encapsulation Protocol, which has been, as said, implemented in many platforms. We'll see which ones. And we have a pretty good API, which basically allows you to do everything that we do present from our user interface in your own. So it's very easy to integrate the data that we produce with your own customer portal, or just to feed it into something else for whatever reason. We don't need any special clients, so everything is a web interface, very easy to use from any mobile. And hopefully ease of installation. This is a little bit of a preview feature, meaning that we are in release candidate 3 now, and probably next week we'll release full packages, so deb and RPM, and it should be very, very easy. You can see the repository, so if you go on github.com/SIPCAPTURE, you will see all of our projects at once, including HOMER, but not limited to. The user interface of HOMER is going to be the main point of access and where you're going to do the job once everything is set up. It's Angular based, so it's responsive and modular. It's very easy to extend and to understand. The previous version of HOMER, version 3, was completely self-built, so the interface was a jQuery big hack, which we discovered was impossible for developers to access and improve or contribute to. So HOMER 5 is actually entirely purposed to make the platform accessible to developers for easy extension and easy improvement, let's say. So it should be something that anybody with web development experience can just step in, and in 5 minutes you're working on. There are no defaults, so everything that you will see in HOMER you can build. There is no static pages. There is nothing that's just there and you have to accept. You can build everything from the search forms all the way down to any statistics or results. You can customize everything to your likes. We support multiple DB options. By default, we use MySQL or MariaDB, but you can use PostgreSQL, of course. And we also support in this new version Elasticsearch and InfluxDB. in and out. So at the moment we use them for statistics. So if you have in any of those databases any information that is relevant to your voice systems, you can easily tap into that from HOMER and mix it with the data that we produce ourselves. It's all based on widgets, and you can very, very easily take one of our examples, fork it to do whatever you want. The best feature, of course, is the SIP search and filtering functionality, which I'll show you later on in the presentation. You can just tap into any standard or customized header that you have in your methods and use that to do the job. Not much here. Authentication API, they're very well implemented. I think anybody would find them proper. It's multi-user natively. You can attach it to LDAP and Radius, or you can just use local authentication if you wish. It is production ready. So we have large operators, including tier ones, using it in production. So it's not a toy. It's something that you can actually use in real life. And we have a very strong and growing community. So there's a bunch of guys that are using HOMER on a daily basis, and they're happy to share their experience and help whoever walks into the platform or needs help getting started. So how does it work? We have two main components in our solution. The capture server is, of course, the central one. So a capture server is actually an open source Kamailio or OpenSIPS instance running the SIPCAPTURE module that we have created. SIPCAPTURE module basically allows the platform to become HOMER. It creates functionality to open HEP sockets, row sockets, and IP sockets, where you can actually duplicate your traffic, and where traffic will be collected, indexed, and stored to database for activity. So it's very flexible, as you can imagine. Everything is defined in the configuration of the platform, so you can go down and create just about anything you want. Once a packet makes it into the SIPCAPTURE module, you can use anything else that you have available in the platform to do something with it. So you can very easily create triggers, alarms, store data in different tables depending on the nature of the method, the user involved, or for emergency calls, for instance, or you can drop methods that you just don't care about and you don't want to store in your database. As we said, you can choose OpenSIPS or Kamailio to build your capture server. We provide guides on GitHub. It's very easy. It's as easy actually as compiling the platform with the module. On the other end, we have capture agents, plural, most likely. You can see in the diagram on the side a little bit how it works. So once you have a centralized collector up and running, you can just enable agents and start sending traffic to it. Now, Asterisk, FreeSwitch, Kamailio, and OpenSIPS come with a built-in HEP agent. So it's just about configuring a couple of configuration lines, and those platforms can natively stream packets to HOMER without anything additional. So it's natively supported HEP protocol, and it works just right out of the box. You enable it, and in real time, you have your packets make it into the platform. The agent role is actually the most interesting one. Our technologies, as you already know, are fully open source. This means that you can create your capture agent. So we provide those which actually work for signaling, but we already created a few experiments on GitHub to also use the protocol for logs, CDRs, QoS statistics. You can send RTCP packets with it. It's just up to you. You can encapsulate whatever you want with HEP. You can send it to HOMER, and once it makes it into HOMER, or well, the SIPCAPTURE module, you can handle it. And we'll have some examples of this down the road in the presentation. The beauty of it is that it really allows you to support any architecture. So it doesn't matter how your network looks. You can find a way to support it either by mirroring your traffic from a switch port to our capture agent, or just if you have the space and the resources, letting the native platform do the job. You can also distribute your capture agents wherever you think you need them. So if most of the times you're dealing with issues from a remote customer, then maybe you want to deploy your capture agent at the customer location and just get the data straight from them, and you'll know what's happening on their network. It can be as simple as that. Or maybe you're troubleshooting your peering or your access. It's completely agnostic. It's up to you how you use it. A little bit about the HEP encapsulation protocol. So we have, this actually was designed initially for the FreeSwitch platform. It was 5 years ago now, and quickly spread onto all the other ones. Asterisk has been, to be honest, the latest one, but it's also probably the best implemented one and the one that brings the most advantages. We'll see how. It's the protocol in its initial form was very similar to Radius, so we were just packing the original payload, the original packet in our protocol and just shipping it to the collector. Today it's a much more powerful mechanism. We reached generation 3 of HAP protocol, and now it's a fully extensible encapsulation protocol, meaning that we define special chunks that vendors can actually create themselves. So the protocol inside is extensible without any code modification. You can define your own chunks. So for instance, amongst platform, you might have data that doesn't exist on another one. There might be an internal parameter of Asterisk that you care about, and of course that wouldn't exist in I don't know, Kamailio or OpenSIPS or FreeSwitch. So the protocol defines vendor chunks, and inside those vendor chunks, the vendor itself can choose what they send and how they send it, how they pack it, how they encode it. So once again, flexibility is the word here. We have already implemented SIP, XMPP, RTCP, RTCP XR, custom logs, CDRs in plain text and JSON format. So that's what you'll find out of the box. Anything else that you want to do is actually very easy, starting from either one of those. Anybody should be able to just extend them and modify them to do what they want. Here's an example of how things are handled inside the SIPCAPTURE module. So this is a either Kamailio or OpenSIPS plan, and you can see literally how you can choose what happens to the data that you mirror into the system. So very simple example, you can have separate tables where you store your calls, correlated methods, registration, info, options, or anything else. Which, as you can see on the left. On the right side, which I don't see on my screen, but it's there, you can choose how to trigger special conditions. So the example that you see here is for our everybody's worst friend, friendly scanner and SIP vicious. What happens when you get those? Usually when you detect those attacks, you either ban the IP or ask somebody in your team to react. With HOMER, you can actually automate a good part of this. So in this specific example, we do trigger. Of course, we insert the data, so we create statistics in the HOMER database to show that we had an attack and the nature of this attack. At the same time, we also trigger a route, kill vicious, which just sends the famous packet of death to the attacker, and hopefully we can stop it automatically. So as soon as you detect the threshold that you deem dangerous, you can try to kill it, or you can ban it, or you can do just about anything. So this is just a generic way to use our detection, our alarms, to trigger some action. It can be as simple as sending an email to your engineer, hey, please, something is happening, take a look, do something. Or you can actually have the system do it for you if you can. And this is what we prefer, actually. Once you have everything, of course, these statistics are available via our API. So they can be displayed, of course, in HOMER, but they can also be displayed anywhere else. So if you have your monitoring system or any other platform where you want to fetch this data and show it, you can. Once again, this is up to your programming skills. You can create something that we didn't think of without any code modification to the core platform. A little bit more about Capture Agent. So as we said, we natively support Asterisk, FreeSwitch, Kamailio, OpenSIPS, and we provide our own Capt Agent software, which is completely agnostic, and it can work with either all of those or any unsupported system. In Asterisk, we have REST-HAP and REST-HAP RTCP modules, which we'll see in a second. What they do, as described, they will mirror SIP and RTCP packets to the platform according to your likes, and once they make it in there, we can have some fun. The same goes for all the other platforms, but we provide a bunch of examples on our website. I was running ahead of the slide. Those are the platforms that we support. We also have a bunch of code examples on our GitHub repository. So what we actually like people to do is to create their own implementation. SIPGate was one of the first companies to do so. So they have a very nice extension which they only use internally, I believe, to HOMER, which allows them to exactly use it, extend it to also cover their CDR and their rating platforms. So once again, up to you what you do with it, but we just put it all together in one place for you to use. Examples can be found for all those platforms, how to enable HEP mirroring. We also support mProbe. You can also use Acme, Oracle, SBCs to mirror traffic using IP. So the field is very broad. What most of our large customers tend doing is to just mirror everything from a switch port. So sometimes you don't want to overload your platform to also do the mirroring. If it's already busy or if it's very critical, you can just mirror everything to a capt agent running on a span port, and off you go. Let's look at how it works in Asterisk. So this is the example, and we have a little diagram as of how it flows. By now, I think you figured it. But yeah, just actually, what is it? 4 lines to enable the mirroring. So you can also protect your stream of HEP with a password, and you can also actually encrypt it. You can also give each capture agent a unique ID. So if you end up having dozens of those agents, you need to know where they were coming from, and sometimes the source IP is not going to be enough. So you can give them an internal ID. You can also have more capture agents running on the same system, to be honest. So maybe one is going to be streaming the logs, and the other one is going to be streaming just signaling. So this is a way that you can use to separate them. Also in the search part. So when you go and filter those messages, you might have duplicates of the same message flowing through your network, and you want to know where you tap. This is what the capture ID is used for. It's very simple for signaling, so it's not nothing fancy there. It gets fancy with RTCP. So this is something that Alexander and Matt Jordan implemented just recently. What it does is very simple. We just tap into the internal RTP engine in Asterisk, and we just take all of those statistics and stream them to HOMER. So you can actually know what happened to the stream, not just the signaling. Signaling is not always what we're after. Actually, most of the questions we received here at the conference were about media. So this is a way, an easy way and a cheap way to tap into your media streams without any overhead or without deploying any additional probes or buying anything else. Of course, the model is coupled with REST HEP because you need to do correlation. You need to know which stream belongs to which session, and that's what it does. On the right, you have a little bit of an example. So as soon as you start streaming statistics, you can just see what happens by session, by device, by trunk group, by IP. This is completely up to you. So we don't give you, we don't force you into a specific way to define your metrics. It's completely up to your team. What we find is that most of the times people want to measure their peering quality. So where you spend the money, you want to see if it's worth it. And yeah, this is pretty much ideal to do the job. It works out of the box. So if you have Asterisk 12 up, this is already integrated, and you can play with it literally within minutes. And build a historical view also of your quality. When possible, we also calculate a MOS score. So when the flow provides enough information, we calculate that on the client or estimate it on the client. If you use an older version at 12, you can patch it. There's a patch available on our repository that you can check out. Of course, it's something that we do not necessarily endorse or suggest, but it's available. Here we have a little bit of an example how we can handle RTCP XR VQ reports, which is something that a growing number of devices are able to produce. And it's a very easy way to tap into your media quality directly at the user agent level. So you can configure the user agent to send those reports to a collector. This collector can be actually HOMER, or it could be capt agent, or one of our capture agents. So as long as this, it's going to send just a published message with the body full of statistics. If you can make this route into the SIPCAPTURE module, you can have custom logic to parse it. So you can extract call ID, jitter, MOS quality, whatever your device is sending, you can extract it. You define yourself what you extract, how you store it, and what you're going to see. So once again, it's completely open and flexible. You can integrate a device that doesn't exist yet. It's going to come out tomorrow. It's going to use a new format, and within a couple hours, you can support it in HOMER, which is something that we value a lot. So we don't lock you into a solution, but we just give you tools to create one. The kept agent specifically works for reports in two ways. So you can just take and store them to database as they are, or as in the example, it can forward them to the core for processing and parsing. Yeah, this is fully working, so you can actually go and play with it right after. As we said, we also support CDRs and logs. So we have a very nice prototype on our GitHub. It's called HAPipe. It just allows you to pipe just about anything using the encapsulation protocol. So you can just take logs, strings. Here we have an example where we're sending a JSON report into the platform with packet loss and jitter. You can mimic something else. You can convert a format you already have to something that you like. Once again, completely open. Once it makes it into the platform, it's just there for you to use, and everything is correlated. So the correlation ID that you will see mentioned here and there, most of the times it's just the call ID. So, or an element of the call ID which you can extend. HOMER knows how to relate sessions. So if you have several call IDs, you also have configuration to tell the system how to put them together. This applies to everything. Signaling, logs, statistics, it all comes together. And I'll show you an example here. We're running to the end. This is how a HOMER search form looks. So you have fields that you can just freely define. So this is not locked in. You can create custom headers. You can do whatever you want. It's all time range based, as you can see at the top right. So you just choose a time range that you want to work with. You just start with some headers. This is the first tier of search. So yeah, time range, filter, transaction type if you wish at the bottom. You can choose also the output type, so you might want to see the results in a table, or you just want to pick up out of it. You can do it just straight out of the form. And last but not least, you can support many databases. So you can have multiple DBs holding your data, local or remote, and you can search one or all of them at the same time. What you get out is something like this by default. So you get a nice table with all of your methods, your session. They're colored by call ID. So you can easily identify what's happening, and when those sessions are related to each other, HOMER will do it by itself. You can also force unrelated sessions together if you wish. Once again, it's all up to you. We try to display everything. The columns that you see here are completely customizable. Yeah, this is pretty much what you get when you click a call ID. So we show you a call flow with the elements involved in this session. This is a single one, but if it was a back-to-back user agent, you would see multiple legs. We support an unlimited number of legs, so it can be as complex as you want. Once you click a specific method, you can see the full contents, so you can inspect all of it. There is no cropping, there is no limitations on what you're going to find in there, as long as you don't rotate the data, of course. And within, you can also, if you have received logs or RTCP reports, you can just display them straight away. So whatever data you have there, it's ready to be shown. And yeah, the main purpose is just to make troubleshooting and investigation a snap. So hopefully, yeah, you get a call. I had a problem. I called A calls B at 12, and it didn't work. Whose fault was it? Mine, the peer, the network, my switch. This way, hopefully, in a matter of seconds, you can figure out where the problem was and point your investigation in the right direction. Statistics, we mentioned them. It's very easy in HOMER to create charts of any kind. So whatever you want to display, whatever you care about having on your screen, whatever you care about looking at for triggering alarms or actions, you can create. So there is no default, there is nothing set. We provide a bunch of presets, but it's nothing limiting there. So you can query the local database or an external one. As we said, we support MySQL, InfluxDB, and Elasticsearch at this moment. This is what you get out of it. So you can just create any kind of chart you want. Here we're looking at usage, registration and invite usage by IP, for instance, which user agents were generating the most traffic on our network, and calculating ASR and ER on the fly. Once again, it's up to you what you want to display, what you want to use. This is an open environment where you can create your own troubleshooting. This is an example of a dashboard which basically taps into all of our supported backends. So you can have at the same time, you could be looking at the methods, the protocols which are on your network, the IPs which are producing or stealing the most bandwidth, the packet rates, method distribution, protocols, server load itself, so you can look at the load of your servers within HOMER. And of course, if you put it all together with logs and everything else, it hopefully produces a very a full environment where you can do all of your troubleshooting. Good. We got to the last 5 minutes, and it's time for questions. I had to run a little bit, so apologies for going so fast, but the time is very limited. The information is a lot. Do you guys have any questions?
So if I was to deploy this in a scenario where I have a large customer and they're complaining about voice quality and I want to put a capture agent in their environment,
sure.
I'm assuming I'm going to use like a Kamailio box that's going to sit in their network?
No, you can, well, the simplest way is to use our capture agent. So we have a capt agent project, which is a very lightweight and performing capture agent. It can run on any system with very little overhead, and it does the job. So you just set a BPF filter, the parts that you want to mirror, the methods that you want to send, and it just encapsulates and ships it back to HOMER. So the only constraint there would be the bandwidth that you use to mirror those methods back to you.
Okay, so then in other words, I would need to take all my voice traffic, funnel it out, and mirror my port, have that go into like a server, some server on their network.
It could be a VM, it could be anything. It's a very lightweight task to do this, so it could be a VM somewhere on the existing infrastructure, it could be a small box, it could be a Raspberry Pi. It depends on the volumes.
But I would have to have a second NIC on that box to receive that mirrored traffic.
Which box? Sorry, I didn't get it.
Wherever I'm putting the agent. I mean, if I'm going to mirror my traffic on the switch, I'm going to have somebody.
This is up to your architecture. So however you can tap the traffic out, you can do it also on the system itself. So if you happen to have, I don't know, something that runs Linux, Windows, you can just deploy the capture agent on the system, and maybe you're looking at a subset of methods. You only want to stream some of those, some of that information back to you. It's very flexible, and we provide many ways to do it at many levels. So we have very complex capture agent, commercial ones even, that can do RTP as well, and then you have the simple ones which are already integrated. So it really depends what you already have. What we push for is to recycle what's already available. So we usually work with our customers to analyze their existing network, their existing deployment, and find where we can tap the information that we need for free, let's say, without adding anything. Welcome.
If you're talking on the order of like carrier grade capture, what kind of hardware are you talking about?
It depends on the volume.
Millions of calls per day,
Yeah.
kind of thing.
Yeah.
For
Well.
a capture agent server, what are you talking about?
It's all about disk space, really. So
I'm talking like processing power, memory, that kind of thing.
it's not very demanding from that point of view. It's all about how you use it afterwards. So let's say the insert part is very simple. So you don't need a very powerful server to receive the traffic. You might need a powerful server to search your traffic, depending on the complexity, the size of your team. You know, if you have one agent or if you have 100 agents using HOMER, this is going to be the factor where the hardware specs are going to need to go up. What we do is, for free, we always consult all of our users as far as, you know, how they plan using HOMER, and we can provide you with specific usage cases where you can get a tune. Actually, we have some on our website that you can sort of, you know, try to look and match to your case. Usually it's not very demanding unless you have many agents searching into it. Yes, please. Sorry, I couldn't hear you.
Are you able to play the RTP stream?
No. So HOMER does not handle RTP at all. at this stage. So we only work with RTP metrics. So we do the job somewhere else. We don't store PCAPs at all. We can generate PCAPs as an export format, but we don't store any packet to disk. We just do everything in memory on the capture agent, grab the statistics, the metrics that we want, and we ship those. So we try to keep it very lightweight from a bandwidth and storage perspective. Unlike other platforms which actually just grab everything in PCAP and they do post-analysis, they tend to be very expensive, as far as maintaining them. They tend to require a whole lot of space and they're hard to just scale. So we don't do that by default. We have commercial probes, to be completely transparent, which do the job. So you can analyze RTP streams, you can dump them to disk, but you don't do this in HOMER. You do this in a commercial probe, and then it's all about the data that you ship out. Anybody else?
Okay, thank you, Laurent.
Well, good. Thank you all for listening. If you go on our website, please contact us, support@sipcapture.org. We're happy to help you all make the best out of HOMER. Thank you, guys.